Hey, I'm Todd Mostak, co-founder and CEO of MapD Technologies. So financial services are inundated with massive amounts of data, and they aren't able to keep up. So they're using these CPU solutions, scaling out to massive number of nodes, downsampling, doing all sorts of tricks, and yet their CPU-based systems simply aren't able to keep up with the massive increase in the ingest of data that they're dealing with year over year. And whether this is hedge funds, whether this is investment banks, whether this is use cases like fraud detection, or perhaps wealth management, they simply are not able to scale to keep up with the demands of their customers, of their markets, of the growing amounts of data they have. And so that's where GPUs come in. So GPUs are a different processing paradigm, graphics processing units originally built to power video games. So organizations are increasingly leveraging these GPUs as a massively parallel way of processing their data. And that's where MapD comes in. So MapD was built, coming out of my research at MIT, from the ground up to leverage the parallelism of these graphics cards or GPUs to literally deliver orders of magnitude speedups over CPU solutions. So queries that would take minutes or hours suddenly are sub-second, and people can do things that they never were able to before because they have this interactive processing power. And moreover, because we're actually running on the GPU, not only can we use the GPUs to run the SQL queries very fast, but we can actually use them for what they're originally designed for, which is actually to render the graphics. So we have this nice 1-2 punch of being able to query the data and visualize it in place, and then even feed it into things like machine learning algorithms. So first, just a general demo of the type of scales and speeds that we can see. This is 11.5 billion records of shipping data. This is a system that would literally bring a lot of CPU systems to their knees, simply because they don't have the processing power to crunch all this data in real time. So with MapD, hold on. Okay, with MapD, we literally can process this data in real time. We can zoom into the Bay Area. We can even get very granular. We're running these SQL queries behind the scenes. You can even see the ships mooring out here in the bay, and none of this is pre-indexed or pre-computed. We're doing all of this on the fly and in real time. So let me cut to something a little more specific to the financial services industry. So one of our partners, Quandl, is actually a provider of alternative data sets to many investment banks and hedge funds. And one of their kind of marquee data sets is this credit card transaction data set, which they actually mine from email receipt records. And so here they have roughly over the last few years, 500 million rows. Not a terribly big data set for MapD, but something that would be difficult to process interactively on CPU-based systems. So here we're looking at a cohorted data set of revenue over time. And I want to show you a use case where we actually explore this data, drill down, see how a particular vendor, how the revenue might be performing, looking at whether we can maybe predict whether they're going to hit their quarter, and then we'll actually dive into it and actually do programmatic analysis on top of the database of this data. So just quickly here, let me start by looking at merchant and number of records. I'll make that into a bar chart. So right away, you can see how fast it was. I could look at Home Depot's revenue over time. You can see seasonal revenue for Home Depot based on this data set. I could also look at, say, Walmart. Walmart seems, going into the end of 2016, to have had a very good quarter selling into the holiday season. One of the nice things about MapD is because we're actually rolling up or pre-aggregating the data, is that we can get a granular view of what's going on. So let me try to get a ground level view of this data. I'm going to add order date. I'm going to add merchant. I'm going to add title, product title, and then I'm going to add the price. And I'll make that there. So we can actually see, we can see the different products that people are buying. If I click on Domino's, we can look at the different types of pizza that they're buying. We can get very granular into the data. So what if we wanted to look at a specific product? I'm going to look for GoPro. So GoPro has very interesting technology. They went public some years ago, and so of course, investors are always trying to track the performance and see whether they're going to meet or miss their quarters. So here we can kind of look at an estimate of revenue by order date through the proxy of this credit card transaction data set. One thing we'll notice is that not all of these items are actually GoPros. A lot of these are accessories, and you can see that in the product price here, $5.99, $10.99. So with MapD, we can just quickly filter that out. I will say maybe GoPros generally cost more than $100. So immediately we filter down to that subset, and then we may do even more granular subsetting. I could break it down by merchant, and we could actually look at basically the revenue stream by merchant over time. One of the interesting things is that you can see that their main channel previously was Amazon, but that channel is actually eroded, and now you're seeing that Best Buy is picking up a lot of the slack. You might also see that it's not clear that the revenue is strongly growing. It's relatively flat here, so that might be interesting to somebody who's trying to develop an investment thesis around the stock. So the very cool thing about MapD is, because ultimately it is a very fast SQL database, we can actually just connect programmatically to the database through JDBC, ODBC, whatever connector you want. And actually, here I'm connected with an IPython Jupyter Notebook on top of the database, and I can do basically farther analytics here. So without getting into too much depth, here I connect to the database. I'm going to pull the estimated revenue for GoPro over time by month over the last few years. I'm going to use something called Facebook Profit. It's an open source library out from Facebook, which allows you to do time series forecasting. Here we can see their estimated revenue going into the future. So it doesn't look so great for GoPro here. Here you can see the deltas between the estimated predictions and the actual amounts. And this is what's very interesting, right? We can actually see what these deltas are and say, hey, because there's seasonality in the data, I can actually use these predicted values to actually see if there's any correlation with future stock values. And here, I find some correlations, but you should talk to me later if you want to chat more about it.